Right, this is part 2 of the notes we did on Wednesday. And we started off with solutions. It's a homogeneous mixture of two or more substances that are in a liquid phase. Now, the solvent is the dissolving medium, otherwise known as the thing that's doing the dissolving. This is usually the liquid. And the solute is the substance that's being dissolved, and this is usually going to be a solid. At this point, what we did is we stopped and watched a video, and you can find the video. It's in Edpuzzle. The link for it is in Google Classroom, and that was rate of dissolving. So if you haven't done that Edpuzzle, be sure that you've got that done. I did take a grade on that. All right, so agitation causes collisions between the solute and the solvent particles. You can increase the rate that something dissolves by changing the surface area. The more surface area, the faster it's going to dissolve. If you increase the temperature, remember kinetic energy is temperature. Ke stands for kinetic energy. An increase in temperature will increase a solid's solubility in a liquid. Now, this is not true for a gas. In fact, if you increase the temperature, it will decrease how much gas will be dissolved in a liquid. Let me do a little blow-up drawing here of that. So let's say I've got a glass of soda, and this one is cold, and I've got another glass of the same type of soda, and this one is warm. There's the level of fluid. And let's say that I've got carbon dioxide dissolved in there. That's what's going to give it the fizziness. In the cold, our particles are going to be moving slowly. They're going to bump into each other less often. And they're going to be able to get out of the soda more slowly. The rate that these are going to be leaving is going to be slower because the particles are moving slower. Also, if they're bumping into each other less, we can have more particles in here. Remember, these are gas molecules. In a warm solution, these particles are moving much faster. If they're moving much faster, they're going to bump into each other, and they're also going to reach the surface quicker. So these particles, more of them are going to leave. So when you're comparing cold versus warm, you're going to have a greater number of gas particles able to be present in cold versus something that's warm. Now, the other thing that makes a difference as far as what influences the rate of solubility is the substances that are involved. If they have weak intermolecular forces, they're also going to dissolve more easily. Solution equilibrium, the rate of crystallization, it's going to be reach equilibrium when the rate of crystallization and dissociation are equal. We can think of crystallization as being particles coming together or coming back together. Where dissociation is the separation of ions. Remember, ions are charged particles. So when we're looking at solution equilibrium, the rate that things are coming back together and forming a crystal is going to be equal to the rate that things are breaking apart, disassociating and separating into ions. An ionic compound is a compound that is made from positive and negative particles. Oops, don't cross the L. There we go. So NaCl is a good example of an ionic compound. When the sodium and the chlorine are bonded together, the overall charge is going to be 0. When they come apart in a solution, we're going to have sodium ions that are positive and chlorine ions which are negative. So NaCl is an ionic compound. When it's held together in a solid form, there's no charge on the particle. When it separates out, when it's dissolved in water, there is going to be charged particles in that solution. An aqueous solution is a solution where water is the solvent. Effervescence just means that it is fizzy due to the escape of gases. A surfactant is a substance that reduces the surface tension of a liquid. An example of this would be dish soap. That will reduce the surface tension of water and the other molecules that are in there, and so it'll break up oils. The next, more vocabulary words. A heterogeneous where particles in solvent are so large that they settle out is called a suspension. Muddy water is a great example. The soil is more dense than water, so gravity is going to pull the soil to the bottom. A colloid is a mixture formed from particles that are sized in between those of solutions and suspensions. The particles are small enough to be held throughout the solvent due to the movement of the surrounding molecules. And of course, solutions are going to be 2 or more substances, and that should be liquid substances, that will not settle out. Now, you can cross out these right here. We're not going to be doing any of that vocabulary. And moved back to, we started the POGIL on solubility. So that's the next thing that we did. And that was the notes for Wednesday. And that is where we ended. We actually